And here we have another video on number theory. That is it. Here it deals with some definitions of number theory. First one is the arithmetic function. A real or complex valued function defined on a positive integer is called arithmetic function. That is, f is the arithmetic function, then it is defined on positive integer to real number or complex number. For example, fx0 x square minus 1, fx is equal to any number x cube plus x square plus x plus 4, anything that gives a real value when for all x belongs to integer, positive integer. Now the second function is the Mobius function. For if n is greater than 1 and n is equal to p1, n can be written in form of prime factor. That is, it is written in form of prime factor. For example, that is 15 can be written as 3 into 5, then 3 to the power 1, 5 to the power 1. These are the prime factors. Then mu n is equal to minus 1 to the power k if alpha 1, alpha 2 dot alpha k all are the 1 and 0 otherwise. If alpha k, alpha 1, alpha 2, alpha k all are other than 1, then it gives 0. For example, mu1, it is defined here. This also the definition. That is, mu1 is 1. For mu4 is equal to 0, that is 4 can be written as 2 to the power 2. Here the alpha is the 2, that is not equal to 1, so it gives 0. Mu7 is equal to 1, that is 7 can be written as 7 to the power 1. Here alpha is equal to 1, so it gives minus 1. Sorry, this is minus 1. It gives minus 1 to the power 1. Again, similarly, mu6 can be written as plus 1. That is because this can be written as 2 into 3, 2 to the power 1, that is 3 to the power 1, that is minus 1 to the power 1 into minus 1 to the power 1, that gives 1. This is 1. Mu n is equal to 0 if n is a square factor. If n is a square factor, then mu n is equal to 0. That is, for example, the square is, for example, this. If n is a square factor, then this is 0. Again, summation of mu d for all d divides n, mu d is equal to 1 or 0 if n is equal to 1 or if n is greater than 1. This is one of the formula on Mobius function, because it only gives 1 for all n is equal to 1. That is, if take an example, that is for n is equal to 1, that is for all n is equal to 1, this only mu1, this summation is only gives mu1, so this will be 1 and otherwise 0. Otherwise, how this is 0? We can consider an example that mu d all d divides n, summation over mu d or d divides n, that is for n is equal to 24. The divisors are 1 2 3 4 5 6 1 2 3 4 6 8 12 and 24. Now mu d, mu1, mu2, since these are the divisor, you can hear the 1 2 3 4 6 8 12 and 24. Here mu1 is equal to 1, mu2 is minus 1, since mu2 is minus 1, mu3 is also minus 1, mu4 is equal to 0, mu6 is 1. We already discussed an example. That is, mu8 is equal to 0 because it has a square factor 2 to the 2 into 2. It is a square factor, so it is 0. Mu12 also a square factor 2 to the 2 into 3. It is also 0. And mu24 has also a square factor. That is, it also 0. So here the sum of the Mobius functions of the divisor of any number is always 0. Now the very important Euler functions. If n is greater than 1, the Euler function phi n is defined to be the number of positive integer relatively prime to n, less than or n less than n. That is phi 1 is equal to 1. Phi 2 is also 1. That is, there is only one number that is less than n and co-prime to n. For phi 3, there is two number 1 and 2. Both are co-prime to n, co-prime to 3. For 4, that is, there is also two number, that is 3 and 1. Both are co-prime to 4. For 5, there is 4 number 1, 2, 3, 4. That all are co-prime to n, co-prime to 5. So here the phi 5 is equal to 4. Here some formula on Mobius function, that phi n can be found by this formula. That is, phi 36 can be written as 2 to the power 2 and 3 to the power 2. Then here the prime factors are 2 and 3. So we can write this is 36 1 minus 1 by 2 into 1 minus 1 by 3. Here this is 2. Similarly, you can find phi 256, that can be 2 to the power 8. That is 256. Here the only prime factor is 2. So 256 into 1 minus 1 by 2. This is 120. Similarly, 515 is written as 3 into 5. So here the prime factor are 3 and 5. 15 into 1 minus 1 by 3. This is 8. Now, some transformations of phi functions. That is, if n is greater than 1, then phi d, summation over phi d is n. We discuss all this form of Euler phi function in example in our next video. If n is greater than 1, then phi n is equal to summation over d divides n mu d n by d. And if n is equal to p1 to the alpha, p2 to the alpha, and pk to the alpha, then phi n can be written as p1 to the alpha 1 minus p1 to the alpha 1 minus 1, p2. All this can be proved from this comes from this formula. Okay, here we also, if we divide this, n can be written. We will discuss all this in next video. This, and phi n can be written as n into product of 1 minus p. This is also comes from now we have another functions, that is unit function, which gives for all value 1, which gives only 1. Now our identity functions here is in is equal to integer functions of 1 by n, that gives only 1 for n is equal to 1 and otherwise 0. If n is equal to 1, that is 1 by 1. Greater than integer function of 1 is 1. For n is equal to 1 by 2, that is 0.5, that is 0. For n is 1 by 4, 0.25, that gives 0. Thank you.